Hi everyone and welcome back to Cloud BI Academy. I hope you are enjoying this Python complete course series. In today's session, we are going to learn two of the most important and most confusing topic in Python. One is decorators and another one is generators. So now let me tell you something honestly. When most beginners first see decorators, they get scared. They see syntax like this: at the rate decorator def my function pass. Okay, and immediately think, what is this at the rate symbol, and why are there function inside functions, and why is Python making things so complicated? The same thing happened with generators. Okay, and think, why can't I just use return? If you have ever had these questions, don't worry. By the end of this session, you will understand why decorators were created, why generator were created, what problem they solve, how they work internally, real world example, interview questions, industry use cases, and most important, we will understand every line of code before writing it. So let's get started. So before learning decorator, understanding functions as object. Okay. So before we learn decorators, we need to understand one very important concept in Python: function as objects. So this means a function can be treated like data. Okay. So function is treated like data. It can be stored in variable, passed as a parameter, and written from another function. So most programming language don't allow this easily, but Python does. So let's understand with some basic function. So basic function is def, create a function, greet, and hello world. Okay. So if I execute this one, so it is print hello world. So let's understand this line by line. So this def greet, we are creating a function named greet. Think of a function as reusable block of code. Okay. This def greet is reusable block of code. And this print statement, print syntax is the code execute wherever the function runs. And this greet is execute this function now. Okay. This parenthesis means execute this function now, and output appear simple. So let I can go one by one. So this def greet, we are creating a function named greet. Okay, think of function as a reusable block of code. Then this code executes whenever the functions run, and the parenthesis this parenthesis mean execute this function now. Okay, so this is the basic function. Let's understand function stored in variable. So now let's do something interesting. Def greet. So most beginner think, how can a variable behave like a function? So let's understand. In first step, we have create a function. So Python store this function in memory. Okay, this message grid. Notice carefully. Here we haven't any parenthesis. Okay, after this grid we haven't any parenthesis. This means we are not executing the function. If we are not using here any parenthesis, it means we are not executing the function. Instead, we are storing the function itself inside the variable. Okay, it means we have store uh, we are storing this function itself inside the variable. This is variable. Okay, and since message now contain a function, so Python executed output appear. Okay, so this will call the greet function, and this example is function stored in variable. It means we have create one function, and that function we have stored in variable, and then we execute it. So interviewer can ask one question: can a function be assigned to a variable? So you can say that yes, function are first class object in Python. You can remember this point. Functions are first class object in Python. So this is the example of function stored in variable. Now let's understand the passing function as a parameter. So this is the one step further. So can we pass a function to another function? Yes. So this is the normal function. Here we have written normal function def greet. Okay. Print hello world. Okay. Then def execute. So notice this parameter. Python expects a function here. Okay. And this line number 5, this executes the function received as input. and this is a function calling. So we are sending greet function as a argument. Okay. So because decorator use this exact concept, if you are understanding this, so decorators become easy. Now third important thing is returning a function from another function. Okay. Def outer. So let's understand this one, returning function from another function. So first we create a outer function here, and inside in we have create another function, inner function. It means in line number 2 we are creating a outer function, and inside it create another function. So yes, Python allow nested function here. If interviewer ask this question, can function like Python is allow nested function, so you can say that yes, Python is allow nested function. And after that we have in line number 5 we have return inner. So here you have noticed we are returning the function itself. It means return inner, it means we are returning the function itself. And now the result contain the inner function. And execute the inners and output appear. So what you have understand here, decorator are built using function as object, function as parameters, functions returning functions. If these three concepts are clear, so decorator will become very easy. So let's understand what problem does a decorator solve. Imagine we have a function def load data, print loading data. Okay. So now the company says before every function execution, and it means before like company says to before every function execution print starting, and after every function execute print completed. So should we modify every function manually? No, that would create duplicate code everywhere. So this is where decorators help. So let's create our first decorator. So don't panic, let's understand every line. So if you go through with line number 1, decorator receive another function. After that, here we wrapper is the new function that adds extra behavior, because as per our requirement we required before running any function we required starting function, and after completing we required function completed. Okay. So wrapper is the new function that adds extra behavior. So this is run first, and then this function is runs original function, and after execution run last function. And this return wrapper decorator return the enhanced version. Let's apply decorator. So after running the thing, we are getting this output: starting function, and when our function is completed, then we are getting function completed, and this is loading data, which is our function. Okay, now let's understand the at the rate. Why? What is at the rate syntax? So instead of load data is equal to this line number 9, okay, Python gives shortcut syntax. It is giving at the rate Mike Decorator. So this line number is, instead of this one, we can use this, and we are getting same result. Let's understand what does at the rate decorator means. So I have already explained this one is equivalent to this. So let's understand with some real world decorator examples. So I have a one best example is there. We can go through with execution time and understand this one with execution time. So let's assume, so this is the execution time. Okay, we are capturing start and end before running our function. Let's apply decorator here. We have line number 9 to line number 13. Here we have applied decorator, and let's execute this Python code. So here we are getting the output: processing, execution time, this one. So let's understand real industry uses. We can use in data engineering, Databricks jobs, because sometimes we are creating our job schedule. So in Databricks also we can use that. In ETL monitoring we can use that. For API monitoring, performance testing, logging, authentication. So these are the real industry uses where we can use the decorator. So let's move to our important one, generators. So first question in our mind: why generators were created? So now let's move to generators. You need number from 1 to 10 million. Okay. So what we follow the traditional approach. So our traditional approach is, so what, this is our traditional approach. Okay. And here we are getting problems like huge memory consumption. Everything gets stored at once. Okay. So Python developer asked, what if values are created only when needed? So that idea became generators. So first, before that, understanding the yield. So let's understanding the yield. Okay. So this is our function. Okay. Here we have created one object and then print next gen. So if I execute, so we are getting only one here. So in our mind, why didn't it print 2 and 3? So because yield pause executions, so it does not terminate execution. So this is the biggest difference from return. Let's write this one again. Then it is print 1, 2. Okay, because it is pausing execution. Let's return third time. Okay. So before moving to next session, first understand the yield versus return. So in return, what happened? For example, I have write one. So this return function only first return execute. Okay. And if talking about generators, so in generators, in generators, it is produce all values one by one. Let's go through with some examples that is asked in a real time, so you can explain that way. So let's understand the looping generator. Okay, so in looping generator, like I have I want to count from 1 to 5. Okay, so for that one we have create a count function and use for loop I and provide some range here. Okay, and yield I. Let's put here counting, and if I execute this loop, we are getting value from 0, 1, 2, 3, 4. Okay, so this is the example of looping generator. Now let's understand some perspective in memory comparison. So if talking about in memory comparison, traditional one consume huge memory. This is the traditional one that is consume huge memory. Okay, and if we use the generator, so it consuming the very little memory. So here we are using the generators. So in interview, uh, this question will ask like difference between list comprehension and generator expressions. So here you can say that list should be store entire data and generator produce on demand. List stores entire data and generator produce on demand. Let's go through with infinite generator. So in infinite generator, for example, we have create this is the infinite one. Okay, and let's call this one, create one object, and based on that object we can call this one, and let's execute it. So here we are get print out 1, 2, 3. So this is the output here. So this is the example of infinite generator. Now understand with some real world use where we can use this one. So in streaming data, we can use that Kafka sensor data, and if we require, we have some live logs are there, so we can use that one. Okay, let's move to understand Fibonacci generator. So in Fibonacci generator, so this is the Fibonacci generator function: a comma b, 0 comma 1 while true, then yield a. So here we have provided the function a comma b comma a plus b. Okay, and provide here, we can provide here one range 1 to 10. Okay, and let's execute it. So first started with 0. Okay, then it is found 1. Okay, so if found 1, then it is print 1, then plus 1, Okay, so till 34 we are getting that one. Now, if we have the large CSV file, so this is a best example in perspective of our data engineering thing, because in data engineering we have sometimes we are processing large number of large CSV file where size is large. That means huge data are there. So this is the example to handle this one. Now, what's benefit we are getting here? First thing, it is consuming low memory, it is faster processing, it is easier for our ETL pipelines and Databricks processings. So let's understand the decorators versus generators. Okay. So for that one, this is the difference between decorators and generators. So if we go by one, so in line number three, decorators use for modifying function behavior and generators using for the generate the data. Here we are using the at the rate symbol, and in generator we are using the yield keyword. This is for the logging, this is for the memory optimization, this is for authentication, generator for the streaming data, decorators for timing, and this is for the lazy evolution. So some sometime you can this question interviewer can ask with you, like what is the lazy evolution. So it is lazy evolution means it is not a like it is taking time or something. It is depend on the requirement. For example, we generate the value, so it is generating value only when required. So that's why it is called lazy evolution. So let's go through with some most asked interview questions. So first start with decorators. So what is decorator? So function that extend another function without modifying original code, that is called decorator. Why decorators are used? You can say that logging, authentication, caching, monitoring, and validation. Next question interviewers can ask, what is yield keyword? So you can say that it pauses functions and return values. And most of the time this question asked by the interviewer, difference between return and yield. So return end functions and yield pauses jump function. And sometimes they can tweak the question like difference between return and generators. So you can say that. Okay. Next thing is what is generator. So here we function using yield and produce value lazily. And advantage of generator, so simply you can say that it is a memory optimization. It means memory efficient, that's why we are using the generators. And sometimes they can ask you write generators expression, so you can write that way, or you can simply write no need to put this one. Okay, so this is the generator expression. And let's understand with the real industry uses. So decorators use for flask routes, authentication, logging, caching, exception handling, retry logic, and monitoring. And generators used for the big data, ETL, Kafka, in PySpark, streaming, file processing, and machine learning pipeline. So today we learned function as objects, first decorators, at the rate syntax, decorator with argument, time decorator, logger decorator, yield keyword, generator, generator expression, infinite generator, Fibonacci generator, memory optimization, real world application, and at the end we have go through with some interview questions. So if this session helped you understand decorators and generator from beginner to advanced level, then like the video and comment day 9 completed, and subscribe to Cloud BI Academy. So and share with your friend preparing for Python, data engineering, and Databricks and interview preparation. We will cover one of the most important Python topic, exception handling and file handling, in our next. Thanks. Bye.